Hello dear students, welcome back once again. Today I will discuss the second part of the previous chapter, light reflection and refraction of class 10 based on NCERT syllabus. So let's start the video.
Before we start, let me say one thing. Still, who has not viewed the previous video of this chapter, please check the link given in the description box below.
In the previous video, we have learned about the reflection of light through spherical mirror and their applications. In this video, we will learn about the refraction of light through glass slab and through different lenses. At first, we should know what is refraction of light. We know that light seems to travel along a straight path in a transparent medium. What happens when light enters from one transparent medium to another? Does it still moves in a straight line or changes its direction? Let us consider the case of apparent displacement of a pencil, which is partly immersed in water. The light reaching to you from the portion of the pencil inside the water seems to come from different directions compared to the part above water. This makes the pencil appear to be displaced at interface. Thus, refraction of light can be stated that the change in direction of light passing from one transparent medium to another is known as refraction of light. We know that speed of light in vacuum is 3 into 10 to the power 8 meter per second. But in case of refraction, the speed of light changes while enters from one medium to another. Some examples of refraction are: the bottom of the swimming pool appears higher than the actual depth of the swimming pool. A pencil partially immersed in water appears to be bent while deep inside the water. A lemon placed inside the glass tumbler appears little bit bigger. The letters of the book appears to be raised while seen through a glass slab. Now the next topic is how refraction occurs. Suppose we have a glass slab PQRS as shown in figure. Here we have two mediums, that is air medium and glass medium. Let us consider a source of light X emits light ray, and after incident on the surface O, it get refracted inside the glass. After refraction, light ray again come out to the same medium. Let and edge be the normal drawn perpendicular to the glass slab. Here I is called the angle of incidence and R is called angle of refraction. So according to the theory of refraction, when light enters from rarer medium to denser medium, the ray get bent towards the normal. Again, when light ray travels from denser medium to rarer medium, it goes away from the normal. In this case, air is the rarer medium and the glass is the denser medium. That is why in this case, when light enters to the glass medium, which is less denser, get bent towards the normal. In this case, angle I is greater than angle R. Similarly, for the second case, angle R is greater than angle I. The refraction through glass slab varies in two factors. That means the refraction depends on the value of the two factors. First is the refractive index of the glass slab and the other is the thickness of the glass slab. The next topic is the laws of refraction. The first law is almost same that of reflection. The first law of refraction is the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie on the same plane. And the second law is the ratio of sine angle of incidence to the sine angle of refraction is constant for a light of given color and for a given pair of medium, that is sin I by sin R equal to constant. The next topic is refractive index. So what is refractive index? The refractive index is the ratio of the speed of light in a given pair of medium. Suppose this is a medium 1 and this is the medium 2. Let V1 and V2 are the speed of light in two different medium. Then refractive index is given by n equal to speed of light in medium 1 divided by speed of light in medium 2, or n21 equal to v1 by v2, where n21 is the speed of light of medium 2 with respect to medium 1. If we write n12, this means that refractive index of medium 1 with respect to medium 2. Again, if c is the speed of light in air and v is the speed of light in a medium, then refractive index of the medium is given by nm equal to c by v. This is the formula for absolute refractive index. Thus, to find the absolute refractive index, we are to calculate the ratio of speed of light of any material with respect to speed of light in air. The speed of light in vacuum and in air is almost same, that is 3 into 10 to the power 8 meter per second. The value of the absolute refractive index of some material is shown in the table. Thus, optically, if the medium is denser, then it has higher value of refractive index. If the medium is rarer, then it has lower value of refractive index. The next topic is refraction through spherical lenses. We know that the spherical lenses are generally of two types, that is concave lens and convex lens. The convex lenses are thin from corners and thick at the center. These convex lenses are also known as converging lenses. But in the earlier topic of reflection, you have learned that convex mirror are called diverging mirror. So the converging and diverging term is just opposite in mirror and lenses. Mind it. The next is concave lens. Concave lenses are thick at the corners and thin at the center. It is also known as diverging lens. On the other hand, the concave mirrors are called converging mirror. The next is properties of concave lens and convex lens. Both the concave and the convex lens are bifocal lenses because it has two focal lengths. That means it has two foci. Foci is the plural form of focus. The focus and the center of curvature in the left side is denoted by f1 and c1 or twice f1. And on the other side it is f2 and c2 or twice f2 respectively. The center of the lens is known as optical center and it is denoted by O. The next topic is the image formation by convex lenses. Number 1. When a ray of light comes parallel to the principal axis. When a ray of light comes parallel to the principal axis of the convex lens, it will pass through focus on the other side of the lens. The second condition is when the ray of light passes through focus. So when the ray of light passes through focus, it will emerge parallel to the principal axis on the other side of the lens after refraction. The third condition is when a ray of light passes through the optical center. When a ray of light passes through optical center, it will pass without any deviation. That is, it will pass through straight line. So next topic is image formation by convex lens. There are basically 6 conditions in the formation of image by convex lens. First condition is when the object remains at infinity. So when the object remains at infinity, the rays will come parallel to the principal axis and after reflection they will pass through focus. In this case, the position of the image will be at f2. The nature of the image will be real and inverted, and the size is very small point size. Number 2. When the object remains beyond C1, that means it remains beyond center of curvature. When the object remains beyond center of curvature, one line will come parallel to the principal axis and passes through the focus of the other side of the lens, and the other line will passing through the optical center and intersect with the first line. At the intersecting point of the two lines, the image will form. The position of the image will be between f2 and c2. Nature of the image will be real and inverted, and size will be diminished or smaller as compared to object. Next, number 3 condition. When the object remains at C1. When the object remains at center of curvature C1, one ray will come parallel to the principal axis and passes through focus on the other side of the lens, and the other line will pass through optical center and intersect with the first line. At the point of intersection of the two lines gives the position of the image. So we see that when the object remains at center of curvature, the image will also form at center of curvature on the other side of the lens. The nature of the image will be real and inverted, and the size will be same as compared to object. Next is number 4. When the object lies between center of curvature and focus. When the object lies between the center of curvature and focus, then one line will go parallel to the principal axis and passes through focus, and the other line will pass through optical center and intersect on the other side of the lens. The image will produce beyond C2, and the nature will be real and inverted, and size of the image will be enlarged. Next, number 5. When the object lies at focus f1. When the object lies at f1, then one ray will go parallel to the principal axis and the other ray will pass through optical center, and after that the two rays will go parallel on the other side, and they will never meet or intersect each other at less distance. This means that the image will form at infinity. The nature of the image will be real and inverted, and the size of the image will be highly enlarged. The next case is when the object is between focus f1 and optical center O. When the object is between focus and optical center in the front side, then one ray will go parallel to the principal axis and passes through focus, and the other ray will go through the optical center of the lens. In this figure, it has been seen that the two rays goes gradually away from each other. So, it is impossible to meet the two lines on the other side of the lens. But on the left side of the lens, if we draw imaginary lines of the two rays, they will meet at a point, and at that point of intersection, the image will form. Since the image is made by Herschel rays, so the image will also form Herschel in the same side of the object. That is, the nature of the image will be Herschel and erect, and the size will be enlarged. The next topic is the rules for image formation by concave lens. The first rule: when a ray of light comes parallel to the principal axis, So when a ray of light comes parallel to the principal axis, it will goes away from the straight path and diverge through an angle. If we see from the other side of the concave lens, the ray will appear to come from focus to the left side. Next rule is number 2. When a ray of light appear to meet to the focus on the other side. So when a ray of light appear to meet to the focus on the other side, it will become parallel to the principal axis after refraction. Number 3. When a ray of light passes through optical center. When a ray of light passes through optical center, then it will go straight without any deviation. So these are the 3 basic rules for formation of concave lens image. The next topic is ray diagram of image formation by concave lens. Number 1. When the object remains at infinity. When the object remains at infinity, the rays will come parallel to the principal axis, and after refraction, they will diverge through an angle. The diverged rays will appear to meet at the focus in the front side of the lens by forming an partial and erect image, and the size of the image will be point size, that is very small size. Next condition is when the object lies at any point between infinity and optical center. When the object remains at any point between infinity and optical center, then the parallel ray will diverge through an angle and appears to meet at focus, and the other ray will go to the optical center. At the point of intersection, the image will form in the front side of the lens. The nature of the image will be partial and erect, and the position of the image will be between focus and optical center, and the size will be very small or diminished. Next is lens formula. Let us consider any type of lens. Suppose we have a convex lens. As shown in figure, let U be the object distance and V be the image distance and F be the focal length of the lens. Let H is the head of the object and H dash is the head of the image. Then we have lens formula 1 by V minus 1 by U equal to 1 by F, and magnification formula M equal to head of the image divided by head of the object, that is equal to H dash by H, or M equal to V by U equal to H dash by H. These are the 2 important formulas for solving numericals. We can also calculate the power of a lens by using focal length. The reciprocal of focal length in meter is known as power of a lens. That is power P equal to 1 by F. The unit of power is diopter and it is denoted by capital D. So dear students, the topic of this chapter has finished. In the next class, I will discuss the numerical problems as given in the NCERT textbook. Till then, bye, take care, and yes, thanks for watching.